The Fish FAD program of the Food and Agriculture Organization of the United Nations is working to improve access to tuna and pelagic fishes by promoting domestic anchored FAD programs in the Pacific Islands region. This video will demonstrate outboard motor troubleshooting techniques for small-scale fishers that can help improve productivity and safety at sea. The two-stroke outboard motor is by far the most popular and common engine used by small-scale fishers around the world. This training video aims to provide information on troubleshooting and maintenance to help improve safety at sea for small-scale fishers. Before you go to sea, ensure you have your engine tied to the boat with a safety rope in case the engine may come loose during operation in various sea conditions. Also, ensure your engine is running well. Listen to the engine to hear if there is any strange sound. Your engine must be running correctly and must clearly show the water pumping out from the engine's water cooling system. Pictured here is the minimum toolkit that should be carried by any small-scale fishing craft going to sea for daily fishing trips. Note the essential open-end ring spanners, Phillips and slot drive screwdrivers, spark plug spanner and spare spark plugs, rope for emergency engine start, pliers and vice grips, and spare fuel hose fitting. The fuel tank providing fuel to the engine is the first step approach if you experience issues with your engine. The fuel hose needs to be connected to the fuel tank with the fuel hand pump arrow pointed in the direction of the engine. Often, as fuel tanks are extensively used, the barb fittings on the fuel tank can become damaged. This can then damage the rubber seal on the fuel hose fitting and allow air leakage and therefore limited supply of fuel being able to reach the engine. This is why we should always carry a spare fuel hose fitting in the tools and spares kit. In an emergency situation, we can remove the fuel hose fitting and insert the fuel hose directly into the fuel tank. As the fuel hose is regularly removed from the engine, when we go to reconnect at the beginning of a fishing trip, sometimes there can be an air lock in the fuel hose. We should remove the fitting from the engine and then place it on just halfway to allow air and fuel to flow and ensure all air is removed from the fuel hose. Now we remove the engine cover to demonstrate where the electrical system begins. As we pull the starter cord, the flywheel turns around, which provides power to the small alternator under the top flywheel, and this alternator provides the power required to run the engine. So the alternator provides power to the power pack, which then provides power to the coil, which then provides power to the spark plugs. This is the electrical system, and in this video, we will demonstrate possible solutions to engine failure at sea and help you return home to your family. With two-stroke outboard motors, issues most commonly encountered will be water and fuel or issues with the electrical system. We will start with the fuel system. Note that fuel used today has additives that absorb moisture. This can result in water in the fuel. Also, fuel suppliers can often have issues with their fuel supply storage during periods of excessive rain. We will first troubleshoot issues with fuel. First, we will drain the fuel filter, so remove the fuel hoses into and out of the fuel filter. The fuel filter, being plastic, is often able to be removed with a rag. Another way can be to tie a small rope around the filter and twist the rope tight to achieve enough grip to unthread the plastic filter housing, unscrewing clockwise. Now we have drained all the fuel in the filter. Often you will see water in the bottom. Note there is a small wire mesh strainer up and under the fuel filter top fitting. Now we will drain all the fuel in the carburetor by loosening the screw at the very base of the carburetor. You do not need to remove this screw, just undo slightly. We also clean the wire mesh strainer at the top of the fuel filter top section. We then ensure we have the rubber O-ring washer on top of the fuel filter bowl, and we reconnect, threading it counterclockwise. Remember to hand tighten only. Now we reconnect the fuel line hose into the filter coming from the fuel tank and out of the filter going to the carburetor. Now we hand pump fresh clean fuel into the fuel system of the engine. Notice the clean fuel now draining from the drain screw at the bottom of the carburetor. Now we tighten the drain screw bottom of the carburetor, not too tight. And now we should have resolved the problem of water in the fuel system. The fuel pump is a very reliable part of the fuel system. It will not normally fail completely. And, in an emergency, you can hold the fuel tank above the engine and hand pump the fuel hose from tank to engine to supplement the fuel pump and get home. If the pull cord rope breaks, we need to remove the top cover to access the flywheel for emergency start. Remove the bolts and top cover to access the flywheel. Here we use some rope tied in a figure-8 knot on the end, and this is placed into one of 2 locations on top of the emergency rope attachment fitting. Then we are ready to pull start the motor. Now we will demonstrate the correct troubleshooting of the electrical system. First, start with the minor components. Never jump ahead to a more complicated part of the electrical system. Therefore, the first step is to examine the spark plugs. Here we are checking if we can see spark when pulling the hand crank rope. Using insulated pliers, hold the spark end close to some metal component and see if you see spark when the starter is pulled. We did not see spark previously, so now we remove the spark plug rubber boots to go directly to the wire end, feeding into the spark plug rubber boots. Now repeat the process. With insulated pliers, hold the end of the wire to some metal and watch for spark as the engine starter is pulled. If you do not see spark, we will then start to clean other electrical connections. First, disconnect this male and female connector. Now use sandpaper or the edge of your knife to clean the metal connection fittings. We reconnect these male and female plugs and we move next to the coil. We remove the coil, which has an earth wire connected. We will clean all these metal joining faces. The earth wire cable lug needs to be well cleaned to ensure the coil achieves good earth connection to the motor block. Now we will check the power pack forward side that comes down from the alternator under the flywheel. We disconnect the plug, remove the yellow fitting so that we can place our tester probes down into the metal connection points. We place our tester probes, black to the earth and red to the incoming power wire from the alternator. If we pull start the motor, we can see if there is power coming from the alternator under the flywheel. Now we remove the top cover of the motor, which has the hand start pull cord rope assembly. Here we are holding the wire that comes down from the alternator and into the power pack. If we use the tester and find no power is being generated when we pull the starter cord rope, then we will have to remove the flywheel with a puller. There are different types of pullers. When the flywheel is removed, we then see the alternator. This is where the electrical system begins. The flywheel rotates around the alternator to generate power, then feeds to the power pack. The power pack feeds the ignition coil, and this feeds the power to the spark plugs. We should always start from the simple side of the system. Start with the spark plugs, and then work your way to the ignition coil, then to the power pack, and only then to the alternator on top of the engine. We remove the stainless steel split clip from the shaft castle nut. We undo the castle nut. And now as we remove the propeller, we must be very careful to note exactly how the different washers are placed on the shaft. This is very important. As we remove the propeller, we then remove the last washer. It is critical to get this washer correct and to ensure all washers are noted in exact order as you remove and then replace back in same locations as the propeller is fitted back into place. The castle nut is tightened, not too tight, and the castle end aligned with the hole through the shaft for the split pin, which ensures the castle nut and propeller cannot come off during use. Here you can see the correct placement of the split pin through the shaft and castle nut end. We undo the lower screw in the outboard leg. Now we undo the upper screw in the outboard leg, which allows air to enter and oil to drain from the gearbox. Note the milky color, which shows some water is entering the system. Also note that both top and bottom screws have a red fiber seal washer. These must be used to ensure the gearbox oil system is well sealed. We now fill the gearbox with oil using a special squeeze bottle. As we squeeze the oil in the bottom, it will then fill the gearbox and come out the top. While we hold the pressure with the squeeze bottle in the bottom, we then place the upper screw with the red fiber washer in the top and tighten tight. We then remove the bottle and quickly place the bottom screw with red fiber washer into the bottom of the gearbox and again tighten tight. We remove the anode at the base of the outboard leg. This provides access to the one bolt inside. Then we have 4 additional bolts to remove, 2 on each side for the outboard leg. Now we undo the gear shaft joint, and at this point, we can pull down and remove the bottom leg of the engine. With the leg removed, we have access to the 4 bolts that hold the water pump impeller housing. We take the top cover off, and this gives us access to the water pump impeller. This impeller is replaced, as it is worn, and we noted that the engine is not pumping water correctly. Note that there is a keyway on the shaft inside the impeller. Here we have 15 horsepower and 8 horsepower outboard motors. We can note that everything we have outlined in this training video guide is the same across all 2-stroke motors. Other outboard engine repairs not covered in this video guide need to be taken to an outboard motor repair workshop that has specialized tools required.